Shall we start? Okay. Assalamu alaikum. Hello, everyone, and good morning. First of all, I would like to thank the University of Gabes and the Institute of Arid Zones for hosting our workshop, Tunprev workshop. And I am very happy to be here for the second time and to start today's session. Well, in this presentation, I would like just to briefly introduce the general scientific background of the Tunprev project and to put you in the picture regarding how we will or we are intending to use remote sensing and modeling climate prediction for to overcome challenges related to drought in southern Tunisia, and therefore to achieve the Tunprev objectives. So in this presentation, will simply serve as a, let's say, a common background for uh, what for the upcoming presentations and hands-on sessions that will be presented and delivered by the local experts, especially Dr. Reem regarding the modeling work and the hydrological behavior of Wad Omjissar, and also the other expert, Professor Hakim and Dr. Malak, regarding the most commonly used remote sensing products and how to select an accurate product to overcome the data scarcity problem. So, okay. So, today's presentation, for today's presentation, I have more or less six headlines. I will first put you in the context and the motivations behind this work or this presentation. Then, after that, the presentation objectives and the case study or study area selection, as well as the data reality. That means what we have as data, what we need, what are the faced challenges, and how to overcome those challenges using remote sensing, which is, we will see together that it's really essential in this data scarce region and environment. Then after that, I will propose and provide you with the overall methodological framework for Southern Tunisia. And I will conclude my presentation by the take-home messages. So the first part is related to the motivation and problem statement. I think you know more than me that in Tunisia, particularly in southern Tunisia, there is like the droughts are becoming increasingly like frequent, more frequent and prolonged. And especially here, as I said before, in southern Tunisia, including Matmata region and Wad Om Jessar. And that was confirmed by the World Bank in his report in 2000, published in 2023. So now, we like the drought, the 2 year or the droughts, we regularly observe the 2 year, multi-year to 1 decade drought in Tunisia. That was confirmed by a study published in 2014 by Mouhi and Lateri. They indicate that 2 year or longer droughts are now common in southern Tunisia. It's really important for us to characterize not only like 1 year drought, but multi-year drought. And the current water resource management strategies in Tunisia or in southern Tunisia doesn't consider the droughts. That's why, there is or we need to revise like this water resource management in order to reflect persistent and widespread drought, as stated by Janay in 2018. So, to my best knowledge, I think there is no prior study carried out in southern Tunisia, in Tunisia, or in North Africa that use decadal, near-term decadal predictions. In North Africa, in Tunisia, like the commonly used method is to characterize the past extreme event, like the drought. But and also we are using climate change projection to have to characterize the future drought, but not decadal prediction. That's why, or this brings us to a major and a core gap, which is the lack of reliable decadal near-term predictions for the next like 5, 6, 7 to 1 decade. So the presentation objectives will be, we will see how we can effectively use remote sensing to overcome the problem or the challenge of data scarcity. Of course, we will use data ground-based observations. We won't use remote sensing as alternative, but as a complement. We will complement the ground-based observations to overcome the data scarcity, which is one of the biggest challenges that hydrologists, climatologists face when working in such complex setting. Then after that, we will see together how we can combine modeling and decadal prediction in order to effectively characterize, predict, forecast drought. And finally, I will provide you with a detailed approach to be adopted for the project in order to characterize droughts. So for the data selection, we choose to select like two or to characterize drought in southern Tunisia at two different scale. It's like each scale complements the other. So at local scale, at watershed scale, we will characterize the drought, hydrological drought. And at regional scale, we will use precipitation and temperature to characterize drought in Matmata region. So for the data, like reality, what we have as data and what we need and what are the issue and problems we face with. Here, as you can see, we have so far a very limited ground-based observations. I think thanks to Mundir provide us with those data precipitation. As you can see here, there is a very limited temporal coverage. For example, Qasr Jadid, like the historical time series is from 76 to 2002, and the others until 2011. So it's appeared clearly that there is like a big problem related to the data availability. And in our case, we need mainly precipitation and temperature for meteorological drought. and we need temperature, precipitation, and other climatic variables such as evapotranspiration, soil moisture, and but also stream flow to calibrate and validate our models. So always, like as I said before, we need we need to start from what is already done. I carried out literature review research, and I have found some very interesting studies carried out in our region, especially here. Like two studies rise as an important and very interesting studies carried out by Adham in 2016 and Professor Mohammed Wassar in 2006. Those studies characterized the hydrological behavior of what Jassar do, water harvesting, and so on. So those studies will be essential and important for our work, and we are willing to use the data like those station in order to achieve our objectives. So it's appear clearly that there is a space re-engage with low temporal and spatial coverage. And in such context, you know more than me that precipitation in arid and semi-arid regions are highly variable in time and space, and we need really highly or densely monitoring network. So we need to find a compromise and between using remote sensing, but also using ground-based observations. Thanks to the advances and the progress in numerical tools and remote sensing, this improved estimate of some key variables such as evapotranspiration, precipitation, temperature, and this development greatly enhanced hydrological and water resource applications. Remote sensing will be an important source to complement our ground-based observations. So we need to select the most appropriate and accurate product among the freely available products such as Sharps, Persian, Era5 to complement our data. But also to characterize the hydrological drought, we will use probably MODIS or GLEAM or Era5 to extract soil moisture and evapotranspiration. In short, remote sensing is not optional, but it's fundamental in our research and project. I think Christian yesterday clearly and perfectly explained near-term climate prediction. So for me I would like to underline that quantifying and improving drought at decadal scale can help to bridge the gap between short term. As explained by Christian yesterday, we have this weather prediction and climate projection. So this decadal prediction is in between. So in between, that's mean for weather prediction or forecasting, we have predictions for 1 day to maximum 7 days. While the climate projection we have for the long term, like until 2100. But we don't have predictions for the short, like near term. That's why the decadal climate prediction bridge this gap, and such decadal scale prediction can inform the water resource management and support decision maker. As you know, like most of water management plan are done for like a scale, a temporal scale of 5 years, 10 years maximum, which fits perfectly with the climate prediction. That's why climate prediction is really important. Here, this table, as I said before and earlier, that there was no prior study carried out in Tunisia and North Africa using climate prediction, but uh, there are hundreds maybe of studies that used climate projections. That's why it's important to make the difference between climate prediction and climate projection. Uh, Climate prediction is a forecast of the climate for the next few years based on the current state of climate. This is the major difference. For climate prediction, we consider the current state, the internal variability and the external variability, in order to predict how the climate will likely behave in the next few years to maximum 1 decade. For example, in our case, we will predict if the next 5 years will be wetter, drier, warmer than usual in southern Tunisia. While the climate projection, sorry, is based on mainly on the what if like scenarios, a pessimistic scenario like and optimistic scenarios based on the gas or greenhouse gas emissions. For the most commonly used climate projections are those of RCP scenarios or SSP scenarios based on what if we have, for example, a concentrate low or carbon dioxide concentration, we will have this, and if we have like a high, we'll have this. So it's based on scenarios, and the main objective is to explore how the climate could change under different human or anthropogenic activities. So we won't predict what will happen in the next 5 years, but the next like 100 years. Generally, we have 40 years and 100 years. So predictions are near term and actionable because they provide us with recommendation for the next 5 years or 10 years, while projections are long-term and exploratory. Well, this is our overall methodological framework. So as you can see here, the very first step is to select the case studies or like which already done. Then after that, we will use ground-based observation and remote sensing to prepare the data input to feed our model, to feed our climate prediction models. Then after that, as Christian presented yesterday, for the World Meteorological Organization report for the next 5 years of prediction of precipitation and temperature. So it was like at global scale. And Ibrahim asked a very interesting question yesterday to Christian. Look, we have those predictions are at global time scale. That means, for example, for Tunisia, it's only with a very coarse resolution, we have like only 2 or 3 pixels. So the idea in our case, we need the downscaling. We need to use this decadal climate prediction to downscale it, to bias correct it, to drift correction, in order to use them. We cannot use them without corrections, without downscaling. It's a very and extremely important step in our methodology. once the data are there, like clean and bias corrected, the next step will be to characterize the meteorological drought. We characterize the meteorological drought in general by using this some drought indices like SPI and SPI. We will use other indices to connect. If you remember yesterday, Christian mentioned a very important point regarding the impact of ENSO, of this this dynamic atmospheric circulation. So it's important to use some indices that reflect this dynamic uh, to try to understand how the drought or meteorological drought evaluate. Then after that, to characterize hydrological drought, we will use hydrological modeling. And the very final step is to provide stakeholders, the scientific community, with long-term decadal drought outlook. So we will try to predict in advance what will happen in the next 5 years simply. So our framework links ground-based observations, decadal predictions, modeling, remote sensing, all those important aspects we will bring together all this in order to produce actionable drought forecast. So the first step is the data collection, as I said before. We will use this observations and combine with remote sensing. And also it's very important for the decadal climate prediction. We will use this, what we call DCPP, decadal climate predictions, a handcast. We won't use the forecast directly. We need first to evaluate the prediction scale. And to evaluate the prediction scale, we need to compare our ground-based observations with like available with this handcast. Handcast, it's like a retrospective. It's like if we are trying to forecast the past. So once the handcast is evaluated and the prediction skills are evaluated, the next step will be to use this decadal climate prediction be forecast in order to have this probabilistic drought outlook for the next 5 years plus CMIPS and serialized runs. As I stated before, this a very important step in our approach that definitely we need to consider and focus on is to bias correct and drift correction. I think bias correction, most of you know bias correction, but for the drift correction, it's a very unique problem that we face when using this decadal climate predictions. It's simply that it means that initialized climate model return or drift from observation initial state toward their own climatology. As I said, for the climate prediction, we consider the current state of the weather, of the ocean, and so on. So the model with time tend to return to his or own climatology, which for sure reduce the accuracy of those data. That's why it's super important to bias and drift correct those data. So we need to consider the bias and drift correction. It's important, it's crucial before starting like the drought prediction. And like yesterday, Christian or Wissel for the hands-on, during the hands-on sessions, we try to analyze the maps, like we selected a country and to extract what will be happening in the future in the next 5 years for the drought. And I don't know if you observed that the predictions have done using what we call multimodal ensemble. So we will use different model, not only one model, but several models. And then we'll average the predictions in order to reduce the prediction uncertainties. Then the next step will be, as I said, mentioned before, the drought metric to compute. So we will translate climate output into standardized drought indicator for analysis and decision makers. We will characterize drought, not only the meteorological drought, but with a cascade approach, meteorological drought, hydrological drought, and agricultural drought. Then the next step, which is we need to characterize hydrological drought at what Amritsar watershed. We selected two hydrological models with different level of sophistication and complexity in order to characterize the hydrological drought. So the time step is at monthly time step. We will use that mean we want to use like a spatially distributed model like SWOT, like Hikashime, so we'll use a very simple models. One génère deux paramètres mensuels, and the other one is TWM, which is developed at our lab at the University of Applied Science. We will use temperature precipitation as input and the forecast as output. The final step is to provide actionable forecast for drought risk decision making. So the result or the scientific output will be like probabilistic maps of meteorological drought. And then after that, the incorporate user relevant threshold for drought severity. So we will have maps and weight that shows the severity, like the spatial distribution or of the drought severity, like moderate, severe, extreme. The take-home messages. We will characterize meteorological drought at Matmata region, hydrological drought at what Amritsar, and we will try to make clear the added value of this decadal prediction, and we will provide the stakeholders with maps and interpretations that are ready to use and to assist farmers and the other stakeholders in planning and mitigating the roads in southern Tunisia. I think that concludes my presentation. Thank you very much for your attention, and I'm very happy to open the floor for the discussion. If you have any question, it's a pleasure to discuss with you. Thank you very much. Yes, sure. Yes.
And they don't think that you need to study the socio-economic drought.
Yes, I think thank you for this very interesting question. You know, I think the main problem for us now is like the data availability, and I think this socio-ecological drought is like the final like final step, like we characterize the exactly. So the idea here, we will characterize meteorological drought and hydrological drought. And for the agricultural drought, it's depend of the available, the data availability, if we have soil moisture, if we will have like stream flow and so on. And then after that, we are working together with Anya here and the others using a participatory approach. So we will involve and use the, like, how to say, the farmers and consider the social and economic aspect to characterize the drought. I don't know if we will have, you know, the project ends by the end of this year, so we don't know if we will have the opportunity to study and to characterize socioeconomic drought. But I think it's important to characterize it. Yeah.
Focus on the global data, right? But drought have impact in many sectors. That's why it's better to see this impact on the social, on health, on economy, on infrastructure, and without available data online, you can download for all the world, you can select just your area and you can download and you can see what happened on the what's the impact of drought on this session.
I think it's it's important to include this social economic aspect instead of focusing only on the scientific like part and based on drought. It's a major problem, and it's not affect only like it's affect people and the economy. So I totally agree with you. It's important to include those aspects, but honestly. For me, I didn't like characterize drought in terms of like or considering socioeconomic aspects, and I think it will be important and key for us to consider it.
So, and the person and population, economy, all these sectors are really affected by it. That's why it's very important to see this sector in the future.
Yeah. I totally agree with you. It's important to include that, but we will discuss this and probably like coordinate with you or contact you in order to consider this. But honestly, I don't know like what are the needed data to characterize if they are available or no. But you said it's open access data, so if it's open access, I think why not? Yeah.
I can add
Yeah.
but here, Madam, just I would like to give brief descriptions about the objective, because the duration of project is 2 years only, something like that. And we have two main objectives. The first one is technical, second one is capacity building. And بالنسبة للبارت بتاع technical science, the scientific part, it is basically focusing on the development of the prediction, the drought predictions, using a legal approach.
All of these elements.
And in this phase, we are focusing only on the modeling, just how to get the map of and the level of drought on the side. So we are الأسئلة الكبيرة حتى تسمي سوسيو stakeholders موجودة في البروجيكت but we are not reaching this.
I think it's feasible. If I don't know the data like needed to characterize throughout that socioeconomic growth, but if it's feasible, if it's open access, why not? You know.
First, we start and we assess the growth hydrological
like a cascade approach.
The integration control and we see the return period, the severity, the magnitude. Also, it's very important because drought is a natural disaster and also is the human activity also leads to drought. That's why it's very important to see his impact on many sectors. I think it's very important.
That's very important.
But if
Very,
Yeah.
to space, I think, honestly. We have only like 6 months. Till
Yeah, the problem, you know, what's the problem? The problem we have on like the project duration, it's only 2 years. And we start focusing on the scientific part like 6 years, months ago. So I don't know if it's feasible, but why not? It could be a very, yeah. It's a very interesting like proposition. So I think, yeah.
Just to complete the idea, we know well that there is a relation between the land uses and the rain direct relation. So it is important for the prediction of the growth to integrate these aspects. The evolution of land uses and the practices, global practices, agricultural practices to the money.
Here, I think we will consider this when using like hydrogen modeling. Hydrogen modeling we will characterize the agricultural growth, but it's important to characterize this socioeconomic effect.
Thank you so much for your very informative presentation. I would like to rebound on the issue, the difference between prediction and projection. And you know, there is a very important step, is the validation, the accuracy of the prediction. My question is, did you go back, for example, 10 years ago and apply the model just for 10 years and then try to compare with the institute ground-based data? This is the question.
Thank you very much, Professor Habib. We need, as you mentioned, we need to validate the predictions using what we call retrospective or handcast data. That's what we call skill evaluation, by skills evaluation, and we will work from 1970 to 2020, or not 2014. This is, we will consider it like as once the model, the skill are evaluated and the model is calibrated and well validated. The next step will be the prediction, like to predict the next 5 years. So it's really important to evaluate the skill, to validate the retrospective or baseline, then after that the outlook. So yeah.
It's not just a success question for your presentation, but a general one. It's about the importance of this work for the agricultural sector. I mean, did you involve people, stakeholders from the agriculture sector, or some, development agencies to use these data in terms of improving the harvest and so on and so on? Because, you know, the time for...
That's a big question.
Already we conducted the first summer school in Tunisia. We spent 1 or 2 days I think here, and that we invite the stakeholders in the regions to explain farmers and to explain to them the output and the objective of those variables, of course. And I think we have in May or at the end of the project, we plan to invite them again and to show the output of the project, like maps, what is the main results and how they can explore them. I hope.
So it's not only a scientific approach, but it's a participatory approach. So like it's like a small living lab. We involve farmers, we ask for their needs, what they want, what their like knowledge, and we will consider this in our scientific approach. And for the agriculture, it's importance. And hydrological modeling will help us to provide some useful insights and recommendations regarding the, like, if there is a drought, for example, in the next 5 years in the region, then maybe what next? Like the management practices.
Even one season. Because
Exactly,
for
yeah.
example, for fruits, that's the extent of the ecosystem is very important.
It's this is the like management practices, like maybe why not changing like the crop, and if one which is resilient, more resilient to drought, so we need to adapt. So using model and methodological approach will give us a clear technical clear idea of the way, and will be like a decision support tools for us and for the decision makers, for farmers. So as Brian mentioned, we will meet next, I think, next November, stakeholders, and then we will prepare maps, and we will try to translate our scientific output into actionable insight. So we will try to simplify the things to be like ready to use by farmers and decision makers. So yeah.
Parmi les objectifs, one of the main objectives of the project is that is to provide to farmers like simple maps in which we indicate the level of the severity of the drought. If it will increase for the next 5 years, it will be and at which level. For example, different regions in the watershed and with different levels of drought severity. So, of course, we not can give a quantitative exact remark, but it will help qualitative. The farmer will understand if he's located this farm in this place, then he knows in the next 5 years the severity will be too high or too low, so he can plan. Yeah, how to like this.
Comes the information shared. How did you manage to reach the farmers in terms of information? Because you know, farmers are not very knowledgeable about these techniques and so on. One of what I think about is for example, if you can build an API with these data and modeling and just a small mobile app, it can be with an open source infrastructure, data infrastructure, it can help. I know this is beyond the project, but it can help.
I think this is important and can be like a good idea to ask for project extension and then include the socioeconomic growth and this because if we have only scientific output, it's not for farmers. They don't like this kind of modeling. If you give a match with 0.7 or about 60%, so it's important to translate this scientific output. Maybe will be the next step of the project.
To assess the spirit of drought, you will use index or which which index you will use?
For the meteorological drought, we will use the commonly used ones like SPI, and for the high drought, we will use the others. I forgot but we will use mainly indexes. Yeah. And decade predictions. This is like the case, decade prediction to have outlook. So we want to work on that. We want to characterize the historical extreme event like drought. But we will give an outlook for the next 5 years using decade predictions.
I have a question about the extension, the special extension of the project. Why did you Marka and the decide on the trip? You say that you would be going to maps or
Like maps, no, but
in my opinion, it's better to work on the extension if you will be very like this.
yes,
Escape.
Yes, but I think more than like to characterize the hydrological roads. We usually go like screen road. And usually for modeling, we work at watershed scale. So the idea is meteorological scale, it's like only this SKI, analysis, we as input only the distribution and conversion. So that's why we say, why not working at the level scale? That's really good. But for the hydrological roads, we need and we use models. And hydrological models at already we are suffering from the data availability. So for the water, we need to work at watershed scale, like using SWOT, using this shared model. It's impossible to work at large scale. So because we need to control, we need actual developer consideration to calibrate and validate our model. That's why we choose to focus on watershed scale, but not just start with hydrological roads. But for the geological roads, as you say, we will work at the regional scale because we need only like precipitation and temperature.
So it would be better to consider a better scale.
Exactly, it is
Type of.
yeah, exactly. This is the idea. So to work hydrological roads at like watershed scale and regional scale, we characterize and predict meteorological roads. Yeah.
The methodology, and now methodology, the first, the draft of the project, of course, and the idea was to implement the methodology for all the southeastern regions, and between, of course, and we cannot, I believe that we cannot try this drought prediction for small regions, examples. Bigger the region is better, the prediction will be. But of course, for the methodology we using, there are some hydrological models. Hydrological systematic, you know that systematically we should small watershed. Why on the side is representative of mainly watershed between in the south, in the hills and the LDB, and mountains, representative. And also because it seems that many researchers think they have already worked on this type, then you will maybe have some kind of comparison in the output of our project with others. Well, that's the idea.
Just one question on how to reach farmers. Bon, pour les applications mobiles, si. Moi, je réfléchis, avec je travaille, on a testé ces expériences, après, ils allaient le donner, il y a عشان niveau institutionnel يعني يكون فيك فبعدين يقول لي أنا نستعمل شوية ديزابليكاسيون عندي سمارت فون ولا باش حاجات دونك فما كود كان يدخل مع النتيجة اللي هو اللي كوتشي اوبريتور معناتها يدخل ثلاثة النتيجة ولا هي الكوبيراسيون أنسيت هي اللي تخلص كل شيء يمكن يدخل الجمهور يكون يقولوا أحد في كونديكتور ما بين الفلاح وما بين شي يوصلوا للمعلومات وإلا الإكستنشن سيرفيس يعني شنو السيادية الواحد يخدم على المعدة ديال البر جماعة السيادية ما كاين كلشي يلزم هذا الثقة ففيها ناس اللي تقع أكثر من جماعة مندوبية ولا غير ولا فما ديزيكواسيون توا كانوا كيخليها يقدر هذيك يكون هو في شي هذيك يعني الفلاح يكون فيه كل شيء ينجم هو ينجم يوصل المعلومة المتابعة وتبقى تجربة معينة.
الإشكال هو هي ريال تايم يعني أن المعلومة لازم توصل صحيحة من مراد
لازم expliquer c'est pas 10 jours c'est 14 c'est 10 ans
من عام
خمسة ل 10 سنين والبريدكسيون وهي تعطي الريزولتا من 5 ل 10 سنين سميت مثال فما الشوفور تاع جمع فيه اكسيتيرا فما لوندور تاع وهذه سي 5 10 سنين انترفال هذاك دونك بالتكرار ديجا بالطون باش تعلم الفلاح سيزون دار 5 سنين جاي باش تصير في المنطقه الفلانيه اكثر كذا يعني
il faut faire le transfert. Alors, nous ne sommes pas des instances officielles pour déclarer la sécheresse. Alors, normalement, il faut faire attention. C'est on développe des choses balistiques, mais finalement, la décision officielle, c'est le CRDA ou bien l'INM. Alors, il faut faire attention à ça. On ne peut pas déclarer la sécheresse. On n'a pas le droit de le faire. Il faut faire, il y a des femmes à un côté institutionnel qu'il faut le prendre en considération. On développe les choses, pas de problème. Donc, au niveau recherche, alors, le côté officiel, il faut faire attention à ça. On n'a pas, au médical de dire, ah, bah, ça serait une bille شايحة ولا تروين. Attention à ça. Alors, le moment, comme le cheval, quand on développe les choses, on a حل في الدين. نخدم كما قالت حنان نخدم عندنا لو برودوي واضح ولا نسكت هذاك السير ديالنا المفروض حنا مع اللي ما عرفتش لا لا بس كذا جاي تشبه مع اللي نعرفوا زميلنا جربوا هو هو اللي يبروبوزي كيف نديروا هذاك الجنرال فكر هذا شوف حاجه ايش ما عرفتيش منه هذا il avait voulu organiser une réunion avec le directeur général de l'INM. مش عارف شقاع اي ولا الناس تسمع بعد ما لا تصدري وين on développe les choses donc au niveau recherche pas de problème اما il faut la décision c'est différent. La seule institution qui a le droit de faire la déclaration, il y a l'INM. Il y a les cartes de vigilance, de tarawih, de كذا. هي اللي هي مخولة. شيء النظام الفلاحة من ناحية الجفاف، je sais pas, je vais écouter n'importe quoi, الجفاف. لكن أغلبية يعني أنا كل كده أعطينا أنا بتفكر علشان الفوق. لا يعني وقت اللي يجيبوا لي زابليكاسيون pour les agriculteurs il faut pas aller لا ما باش نمشي مش لا حتى pas من البروجي طبعا les applications اللي يعملوا في الفلاح توا ce sont des applications موجودين في l'irrigation موجودين أما هكا يبدا الستاسيون اللي نتاعو في وسط البارسل تاعو il peut وقت piloter par exemple l'irrigation à distance موجود partout في تونس هلا في التطوير في المدينة في un peu partout في المدينة فنحن معك ليبر اتونسيف عنده فلوس لا يعني لا باش تستنصر مكتوب ب 4 دقائق مش سهل avec des facteurs avec كذا مش فلاح عنده 4 زوجات مش عارف كذا عنده
ايش يعني مثلا عنده شي ملاحظة
بس l'approche, bon, les inputs de vérifier, mais on va les donner pratiquement constants, la température mensuelle et cumulative. Donc, les sorties, soi-disant, à l'approche de l'année, la partie de l'année, output par mauvais, pour chacune pratiquement un système par rapport à la moyenne de l'actuel. Et dès que la température est dans les 50 qui veulent la commune. Voilà, là, on dit que c'est que la distance, plus ou moins, elle est égale.
Voilà.
Avec attention.
Chaque présentation, donc parce qu'on a des intervalles de vision à la phase organisée, c'est à la nationale.
الكلاس كان معروف زعما مثلا الكلاس مع النورمال
À l'approche, le point approche. Donc, un donné, deux données, une unité peut-être, soi-disant, l'output, ce sont les températures et les pluviométries. Avec
لا les indices ماشي
des indices.
هذوك لي دوني غتستخدموهم باش نكالكوليو les indices
صحيح. خلينا نكتبوا les indices. أول أنا باش نكتب les indices هذوك ندخل على الموديليزاسيون تhéologique. Les modèles théologiques, ce sont les quantités de l'évaporation, les quantités de modèles. يعني دينام journalier ولا mensuel ولا annuel. Voilà. Donc, couplage des détails, c'est comment faire le couplage. C'est-à-dire, couplage, 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 c'est-à Mais puis, l'approche comme les modélisations de l'OPI, avec une approche idéologique اللي هي تضل تشمل الجورنالية. فهمت كيفاش؟
لا احنا ما نخدموش بالنظام الجورنالي. ما يسمى انا نشرح لك الموديل الايديولوجي شنو غندير هنايا. غندخل لي زينبوت مثلا بريسبيتاسيون تمبيراتور على حسب التيب ديال الموديل، واش اراسفيزيك ولا سميتو ديستريبيوني واش كونسيبت ديال. دونك حنا لي الموديل اللي عندنا كاين واحد فيه بلون بارامتري deux paramètres mensuels, l'expression G à 2Z, deux paramètres mensuels, température ou précipitation. Qui est modèle AHA, il est complexe chiffrier. Là, la masse a une comparaison, parce que je vois l'impact de la complexité de modèle, alors il y a les résultats. Moi, je suis un modèle, je vois que les différents sur un carré, on va valider le modèle en utilisant des données input. Parce que le valider le modèle, كاين لي زوبسيون، كاين اللي معروفه كلاسيكيه وتراديسيونيل وسترن فلو والديلي. دابا مع هاد المسانسين كاين اكشوال ترانسبيريشن سواء الموديل ولا الديام ولا هذا الموديل. اون فوا غيكون عندنا موديل بيان كاري مثلا وفاليدي، غنخدمو عاوتاني داك سترن فلو اللي غيكون مثلا في نيكست 5 years 5 سنين الجايه غيكون عندنا سترن فلو بحال حتى هو داير نوت بريديكسيون. فهمتي؟ دونك هذا غنكالكوليو دي زانديس اللي كيعطيونا إذا هذا الهيدروجينال دروت. يعني الهيدروجينال دروت غنكاركتيريزيوها ونوتيليزون لي موديل هيدروجين.
يعني دي زابروش سون باراليل.
فوالا بالضبط. كل واحد كتستعمل بحال اسبريا. Déjà, l'approche de la structure, ma SPI 3, SPI 6, en fonction de la structure. Voilà, ça c'est le problème. Le moins de la question. Voilà. وإحنا هاد البريزنتيشن اللي باغيين نديرو هنايا ديال 5 ماشي ديال مثلا ماشي هو الفوكاس. اصلا علاش هادو اصلا ديكريو زعما مزيانين، حيت بالك 5 سنين الاستراتيجيه اللي كديرهم دابا حنا ماشي سي با فورسيمون غنفيزيو حنا خالص. الا ما عندناش مثلا اهليه ولا خاص حنايا نديرو اوتيل ديال لا ديسيزيون، يعني كتقول لهم ها هما داخل هادو وماشي غير الفارما. راه يقدر تعطيها لي زاجونس مثلا ديال الهيدرولوجي ولا الهيدرولوجي فوالا. فوالا حيت الفيزيون كيكونوش على 6 شهور ولا عام، لا كيكون على سنتو غالبا. كاع ديك لي بلون ديال سميتو كيكون على سنتو. داكشي علاش هاد البريديكشن اغلبيه كيديروها على سنتو. فهمتي؟ دونك ماشي بالضروره لوبجيكتيف هو المشان لا يدير هذيك ولا دير النقاط، ولكن تعطيهم دي ريكومونديشن في اوتيل ديال لا ديسيزيون. دونك غتعاون وديك الساعه الديسيزيون هما اللي غيكونتاكتيو لي فارماس و
أنا ما ذكر كبير في التساؤل في الصحة.
داكشي علاش كنستافدو من هذا صراحه العلاقه بين المسافه.
أنا on apprend de toute façon, on apprend. ما سوري أنا في الأبروش سويت مثلا في البيوغرافي والله لا بعض أنا أعطيك الريفيو في عقراو في المغرب effectivement ما يعمل كلاسيفيكاسيون هيرارشي وفيها لي زاسبي الكاليتي سول فيها البين فيها même le socio-économique composant كيعملوا
Précision, tout ce qui est météo, hydro, c'est une pression de le contexte socio-économique, tout les avoir le socio-économique, finalement, هو finalement le drive هو الكلمة. بعدين يجي الإيديولوجيا اللي تنظم السوشيال. D'accord. Alors, c'est les stratégies de mitigation, pour éviter les effets. Ouais, les stratégies d'adaptation, ça veut dire avec le contexte.
عشان هذا الميثودولوجي واش كتشوف كتاخد دي زاسبي هكا وكتشوف شكون هو اللي كيتبارطاجي بزاف لا لا هو
vulnérabilité. يعني لو كده قديش تبدأ
يعني ناخذ ديفرون بارامتر يعني موبيليزون
واش ماشي ديك الميثود ديال الخلاصه ايش ما رايتش به داك العمليه شي
c'est trop
c'est très subjectif.
نفس الوحدة مستقبل مع كل لا لا بقول لك أنا في مجال هو اسمع البيت فعلا طبعا فعلا طبعا لا يقول انا صار كذا سوى حتى نعمل من كذا باش نسلكوها ديريكتومون على على ليستي لكن ما نقولش 100% لكن نورمالمون خفض لا شك في عندي 10 سنين مستحيل واحد عندي في اليوم لا لا ما في هذا الكتاب بالنسبه لي انا السير الكتاب هو الاول من هو جماعة
Yeah. Get a call from Mustafa.
We can start. Microphone. نبدو ميكروفون. هذا ما نعرفش.
هذا إذا قرب شيء شوية.
باهي أوكي. هكا صباح. صباح هذا. نبدو. We can start. I will start by presenting myself. Good morning. I am Dr. Malek Hinshiri, Assistant Professor at the Highest Institute of Water Science and Technique of GABIS and a research member in the Laboratory of Ermology and Combating Desertification in the Arid Region Institute of Medellin. Today I will give an overview about monitoring the agricultural drought and its interaction with climate change in North Africa from 2003 to 2023. Okay, the research follows a structured approach, beginning by the introduction, followed by the issues. Next, we will talk about the objectives of this study, and we will show the study area. Then I will present the material and methods of this work, and the result discussion, and finally, conclusion. Global warming and human activity are making drought more frequent, prolonged, and intense. This increase in drought reduces water resources, which directly impact agriculture as well as food security. Throughout remote sensing technology, we can monitor drought pattern over time and across region, helping us better understand how water resources are changing. In this presentation, I will show North Africa, but I will focus almost on Tunisia. So we focus on 4 key research questions. First, we will see the different drought indices in identifying drought condition across various time scale. Explain the spatio-temporal pattern emerge in seasonal indices during period of drought condition, and we will assess which type of vegetation cover are most vulnerable to drought risk, and how does the shifting between vegetation and desert occur during extreme drought event. Therefore, the main objectives of this study are to evaluate the efficiency of drought indices for drought monitoring in North Africa from 2003 to 2023, compare the shifting between vegetation and desert during dry and normal years, and determine which vegetation cover types is most vulnerable to drought risk. This map shows the location of our study area. This all the North Africa, which is surrounded by the Mediterranean Sea in the north, the Atlantic Ocean in the west, the Red Sea in the east, and the West Africa in the south. But in this today, we will talk only about Tunisia. Right? The elevation map of our study area, which is North Africa, varies from 366 meter to 4,144 meter, while in Tunisia it ranged from the sea level to 1,544 meter in the highest altitude at Jbel el-Shambi. This, the land cover map over North Africa, it shows the different land cover category over this region. This diagram illustrates the methodological framework used in this work. First, we use the CRU data to calculate the drought at different time scale using the SCPDSI drought, calibrated Palmer Drought Severity Index at 1, 3, 6, 9, and 12-month time scale to check the drought events, its severity. Also, we use various data from various websites, satellite data. We start by the MODIS data, the vegetation data to calculate the VCI, vegetation condition index. Also, we use the MODIS data to calculate the temperature condition index. And we use the TRMM data to calculate the precipitation condition index, and the GLADAS from Giovanni to calculate the soil moisture condition index. After this, we will select dry years and wet years. Then we will see from the land cover map, we will select the dominant vegetation types, and we will check the impact of drought on those vegetation types using those indices. And next, we will, based on the land cover map, we will create a map only to show, because we have the land boundary between Africa and the big desert, and always we have shifting, and this band, it's very important for researcher. That's why we want to see the shifting about the vegetation. We combine all the vegetation types to one class, and we have and second class for desert. Then we check when this vegetation shift to north, when to south. We will check this variation and compare between dry and wet years. And at the end, we will do some statistical analysis using correlation relationship and the trend analysis to check all this point. I already talked about the data set used in this study from the Climate Research Unit, from the Moderate Resolution Imaging Spectrometer data from the MODIS, and the rainfall also, and the soil moisture from the Giovanni website. I try to use different, especially we can get all the types of data from MODIS by I want to use various data. Why? To check the efficiency of this data. if we can use this data or this data, the variety of this data on this area or not. But always we must use the same resolution. We can't use one example data for 500 meter, another for 1 kilometer. This is not logic. Always we must, when we do research on when we want to analyze any phenomena, we must use all the data with the same resolution to have result which is specific and clear and also correct. This data set was used to calculate, as I talked before, the PCI, the precipitation condition index, the vegetation temperature condition index, and the VCI, the vegetation condition index, and soil moisture condition index, using this equation, and the calibrated Palmer drought severity index at both short and long-term scale, as I said, for 1, 3, 6, 9, and 12-month time scale. As a result, here I focus only on Tunisia. I delete the other country. We have five countries which cover all North and Africa, but here I focus only on Tunisia. For Tunisia, PCI here in this figure, PCI, which is in red color, highlights strong rainfall seasonality with higher precipitation concentrated in December and January, the raining season for North Africa, and extended dry period during the rest of the year. For the PCA is also accompanied by reducing vegetation condition index, this curve which is in green, higher thermal stress, which presented here in orange color, and declining soil moisture index jointly indicated the onset and the persistence of drought impact on vegetation. Here I want to check the relationship between vegetation and the climate element, precipitation, soil moisture, and temperature. This maps for mean PCI from 2003 and 2023. I can't put all the maps, I select the K years. These maps reveal clear spatial variability in rainfall across. Here I will talk only on Tunisia. Here it shows variability in rainfall across Tunisia, with relatively stable precipitation along with the north region of Tunisia. Always it's raining, we have raining season and the amount always is high. If we compare with the central and the south of Tunisia, we always in the south of Tunisia, it's arid region and we have very little amount of precipitation. Going to the soil moisture condition index maps, it indicates higher soil moisture availability in North Tunisia, while central region show moderate variability. Southern Tunisia consistently exhibit low SMCI value, reflecting persistent soil moisture deficit and confirming the severity of a drought condition in this region. Going to the TCI maps, it shows lower thermal stress in northern Tunisia, while central region experiences moderate temperature variability, but in the south Tunisia, low TCI value indicated high land surface temperature, which intensifying the evapotranspiration and aggraving drought condition in this region. Going to the vegetation condition index map, it indicates high healthier vegetation condition in northern Tunisia, supported by more regular rainfall and higher soil moisture. In contrast, the southern Tunisia show persistently low VCI value, reflecting vegetation stress and reduced agricultural productivity under recurrent drought condition. Here we see that the precipitation is the main key for the growing of vegetation for the Tunisia country. This is the self-calibrated Palmer drought severity index. We use this index at 1 month time scale, 3 month time scale, 6 and 9 and 12-month time scale to check its impact on vegetation. What we found, we select the most dominant types of vegetation, which is grassland, cropland, and for forest, I put forest only because we have forest only in the northern part, but grassland and cropland we can found on central and south part of Tunisia. Yeah. We found that cropland is very sensitive to drought risk. We have here on 2011, also 2015, we have very sensitivity to drought risk, and this type of vegetation is very affected and impacted by drought condition. This table, This table shows the different land cover class. I select 3 dry years and 3 wet years. For dry years in 2009, 14, and 19. For the wet years, we have 2006, 2020, and 23. And we have the area on hectare. We mentioned that here we have the grassland, more, as we talked before in the curve of the SCPDSI, is more sensitive to drought, and we have variation between dry and wet years. Sorry. Sorry, here the format changed, maybe from the laptop. In this area, I told that in this map we have 2 main types of land cover. We have the vegetation and we have the desert. This map shows the shifting between the desert and vegetation. We noted that during the dry year, the vegetation part shift. The desert part shift to the vegetation area. Here we can show drought years. It's 2004 with the red color. You can see red color, and this is Tunisia, which have that that point with the red color. This is part for Tunisia. It's clear. Yeah, the red line, that red line mention the drought years, limit of the drought years, and the blue mention the line of the wet years. Mean this the limit where vegetation can extend, the limit of the extent of vegetation during the wet year, and during the dry year where the desert can move. We found that during the dry year, the part of the vegetation area turned to the desert. And in contrast, this vegetation during the wet year moving to some part of the desert years. And we calculated this area. Now, we will assess the correlation of drought indices for Tunisia. We found that this correlation from weak to strong, the strongest positive correlation is observed between SMCI and PCI, indicating that precipitation playing a major role in controlling soil moisture in Tunisia. VCI show a positive correlation with DCI, suggesting that vegetation health is influenced by temperature condition. Moreover, TCI exhibits a positive correlation with SMCI, VCI, and PCI, highlighting the interconnection influence of temperature and precipitation on both soil and moisture and vegetation. This figure shows the correlation of these drought indices for Tunisia. They show from the strongest correlation to the lowest. We start by PCI and SMCI with the correlation value of 0.6075. Next, we found a correlation between SMCI and TCI with 0.70, and between SMCI and VCI with 0.62, and the lowest was between TCI and PCI with values of 0.64. It's not very low, it's good, but it was the lowest from all this relationship. In summary, adopting resilience and innovative farming practices is essential to increase crop production, protect the environment, and strengthen the adaptability of farming system to climate variability. As a regional phenomena, drought must be monitored both spatially and temporally to capture its full variability and impact. Satellite dataset from MODIS, from TRMM 3B43, and from the Gladys Giovanni climate model show a strong consistency in the timing of drought event throughout spatial pattern vary. Also, the drought indices PCI, TCI, VCI, SMCI, and the SCPDSI at different time scale provide a comprehensive understanding of drought dynamics and their complexity. Land cover analysis indicate that croplands are particularly sensitive to drought condition for Tunisia. And the shifting analysis enhance our understanding of underlying drivers and their broader implication for ecosystem and community. Thank you. If you have any question.
You have one question?
Yes. Okay.
Thank you very much for this
Thank you.
very interesting presentation.
Thank you.
My question is related to the use of the data.
Yes.
We know that there is freely available
Yes.
products
Yeah.
that you can take data from them. And why exactly you choose say
CRIU. Yeah.
And one is for rubber aspiration and the other for monster. I mean, why not, for example, helium or AR5 or the other products?
Okay. Especially I select different data. Why? Because I am doing research. I am trying. I don't know this area. I need to know my area of research. I need to assess my data, to check my data, which data set was better for giving some result. That's why I tried different websites. For CRIU, I select because CRIU provide data from I think 70 or 60, 1960 or 1970, and I need the long historical data. Long time series to check really the change. And for MODIS start from 2000, right? We don't have before data set. I tried even for climate elements, I tried to use different types of data as I talk, because I want to try the data. I want to know which data is better to use in my future research. I found that almost all the satellite data give good results, especially the MODIS data. After all my research I did with the MODIS data for climate or for NDVI or for the land cover. Yeah.
Yeah, because like for me, I had I compared green and MODIS in Morocco, but also in Greece.
Yeah.
But for modeling, for water resource management and not drought mitigation.
Yeah.
And the results were that green, greatly, clearly outperform MODIS.
Yes.
Yeah, that's why there is no single product adapted to all. For example, it happens that
what's the resolution of that data?
You mean is it the spatial or
spatial resolution?
For the spatial resolution, MODIS is better.
Yeah, that's why. Because
what is the resolution? Temporal resolution?
Not because not only temporal. I use also spatial. If you study large space, you need to use only single data to avoid that errors between. If you want to do the assemblage of the maps, you will have errors. That's why if we want to study an area, first thing to know the area of your study. Then you will select which data you will use. And for sure, we will use the better spatial resolution available for that, which cover all that area. I found that models cover large scale because for me, I work over all Africa, North, West, and also I study the South Africa. I can't use data which is cover a small area and I will do many image, not logic. That's why for me, for my study, it's this. But if I want to study small area, for sure, I will select another types of data. It's depend always on your area of study.
For in in our case, yeah, you're right, totally right that models the high spatial resolution, but with a low temporal resolution.
Yeah.
For models, we have like one value, which I think it's 7 days, like the 10th step. It's 1 week, I think.
We have 1 day. Some data have every 1-2 days, other for 16 days, like vegetation. But for climate, we can find every 1 or 2 days. Some data are available. It's depend on your research and on your topic. You select this.
Yeah. For example, we want to use remotely sensed product.
Yeah.
For precipitation, to extract precipitation.
Yeah.
In southern Tunisia.
Yeah.
You know the reality of the region. What do you think? What is the best product? I mean, is it AR5? Is it this CRU or which one? Or it's better to compare those.
We want to study Tunisia or any other region in the world. If the study area it's very small space, a small area, not big.
Small and big.
For small and big, because the small area give more better result. You will give
At the level of the country, at the small region.
I don't understand the question. If you can clarify.
Differentiation between what is big and what is small.
Big and small area, which better? Yeah. Yes.
For example, if you mean by big the Northern Africa.
Yeah. No.
At the level of the country, is it small?
It's so small. Yeah. For Tunisia, it's small. Yeah. Not all Tunisia, some part, example Medellin, example, you understand? This area is small, but if you want to study all Tunisia, it's big, not small.
Because it's relative.
It's depend on the area. Yeah.
Can I ask you a question?
Yes.
Thank you for this informative presentation.
Yeah.
First, I would like to focus on for Tunisia, we don't speak about grasslands.
Okay.
We have rangelands.
You know why I renamed this grasslands? Because I use the EGBP classification, and this it's because of the reference, and because I need to publish this, I need to use like with reference, not from.
Second, for the study of drought, we have the reversibility.
What?
I mean, when you have a drought, we would like to see the impact on the behavior of vegetation.
Yeah.
For example, I didn't see there is a wet year on 2004. It's wet year.
Yeah.
2018. It's wet year.
Yeah.
So I suggest to you that maybe at a later stage, we focus on the reversibility, because as you know, drought is an event-driven phenomenon.
Yeah.
And this is as you know, in the Sahara region in Africa, this is the famous case of the greening up of the Sahara after the desertification in the 70s. So these are two points. The third one is I'd like to see the correlation between PCI and PCI. PCI is precipitation, right?
PCI and what?
And DCI.
I did this. I did this in the presentation between PCI and VCI. I did the correlation between all the indices.
And it's a good correlation.
Yeah. Yeah. For your comments about the year's drought in Tunisia, maybe I did because today when I know about this workshop, I delete all the other country and I focus only on Tunisia. but the select of the year, it's I select this year based on all North Africa. Maybe not the same year you told, because example in Morocco, sometimes it's drought, in Tunisia not. It's depend. It's all of them are North Africa, but it depends. The severity it depends. It can affect one region and didn't affect another region. That's why maybe the select of the years not the same in your mind. For the second, for next part, I found this correlation between VCI and PCI. It gives a good correlation, and we found that the driver of drought in this region, it's the PCI, the precipitation. If we have deficit in precipitation, this it leads to drought, and it affects the vegetation.
Yeah, because you know something, especially for the southern part of Tunisia, and there's similar cases in the region.
Yeah.
When we study vegetation, we have to avoid the effect of the annual vegetation, especially after the rainy season.
Yeah.
So we avoid the effect of the annual vegetation because it can impact our results.
Yeah, here it's monthly time series. I will show you. Here, sorry. This is the SCPT assigned different times. For the special, I put yearly, but for the time scale here, the trend it's monthly, not seasonal. But in the legend, I put only the years.
Just a general suggestion of
Okay.
the study of vegetation towards the drought. Another point is related to the resolution of the imagery used in the study. This is a later work with our team.
Okay.
Why not using Landsat data?
Landsat, it can't cover all North Africa. It covers small area.
No, it covers all Africa.
All Africa.
Yes.
I don't
but
listen.
It's a cover of 40 years with a good resolution, 30 meters per person. But the problem is that what I want to ask you about the downscaling of other data.
Okay.
This is the maybe you are more knowledgeable about this. The downscaling, does it impact the quality of the data and the results?
Yeah. Always we think about the special resolution. If we want to have good result, we always must to select the smaller resolution. For the Landsat, it's 30 meters. It's the best, I think, more better. But I didn't use because before I know, as you teach me, it covers small area. That's why I focused on using modest data for 500 meter or 1 kilometer. Yeah, you have any other question?
Thank you. This nice presentation.
Thank you.
The topic for me it is you understand. I have some questions.
Okay.
How using satellite measuring to identify the type of vegetation that
example.
Grass or tree or
I will explain. Inshallah, in the hybrid session later, I will show how to download some data. But now I will explain. If we want to identify, you need to download the data from the MODIS website. It's example you select, and you have guides. Example, if you want to select the data, first you select the resolution. We have different resolution, then you select the data, and we have different classification types in this website. Then when you want to download this data have the data have guide. You will download that guide. It have code from example. For me, I use the EGB classification. It's from 1 to 17. Right? Because it covers all the world. Some classes we don't have in North Africa, like Savannah example, but we have in the west of Africa. Each code, when you download this data, you will open in the GIS software. Then you will have this shapefile. It's shapefile, right? polygon. It's polygon with one color and one code. And you will check this guide. You will find the legend of this number. After that, with the GIS tools, you will prepare your maps. You will create a land cover map with legend, and also you will select your study area and make this map.
Can I add something?
Yeah, sure.
Because I think the question is about how to create the land cover map focused on vegetation. That's it.
Yeah, to identify the type of vegetation. But for validation, always agree how I can identify it.
In the past, you know, this is the point. This is the point because Malek has used regional focus with the data with 300 meters resolution,
Yeah.
spatial resolution. You can see 80% of Tunisia. You can see nothing. You see just desert, which is not recommended. I mean, for if you focus on at the country level, you see, the normal, I mean, the classical way is to get the data at a higher resolution, I mean, 30 meter, 10 meter, you can even reach 50 centimeters per person, which is commercial and very expensive. Yes, very
Yeah,
expensive.
I have also. Okay, you can continue. No, let him continue, and I will say another thing.
So, what is used in the study is the reference data with the global coverage, with the classification scheme and categories based on the global aspect. This is why we discussed that we need something on Tunisia. We focus on our classes, for example, related to rangelands, to sound encroachment, to many aspects that we have in Tunisia, and not we can find them in this global reference. But it depends on the classification scheme. Very important things also about the training data. We have to do our field work, ground truth, exactly, to validate our final maps.
Yeah.
It's very important.
I can say something. You know, I have a research which reply to your question. Before we don't have example land cover map before 2000 because the land cover map available on Modis data only from 2000, and if we want to do research and we need the land cover map before example the 1980, we don't have maps. What we can do? For this, I do research about the time series of land cover map over Africa. I have this paper is already online. And we use the AV-HRR data, it's NDVI data as input data. Because it shows the vegetation, the normalized difference vegetation index from 1982 to 2015. We use this time series data, it's annual data. And I use the Modis data, land cover. I download this data from Modis website as reference data. And I did also the photo interpretation. We can example, if you want to do a study and you can't visit this site, always if you want to have good result, you must do the field work. You go inside, you take GPS, you collect the point, and you export this point to the GIS software, and you verify this point. Because if you want to create a product, at the end you need to evaluate this product. You can't create a map and say, this is the map of land cover. No, you must to improve that this classification, it's good and it's give a good result. And as I say, we use the AV-HRR data as input and the Modis as reference data. We select the unchanged pixel. Example, we take 2002 and 2012. We take 10 years interval to check which pixel didn't change. And we take those pixels as for different class, for different types. And we select this point as region of interest. And we did the classification for the AV-HRR data. We apply this classification. Then Also using the MODIS data and using the Google Earth engine and the Terra Incognita software. This is a very good software with the high spatial resolution. You can see what even few meters in soil, and you can see what we have in our Earth. To verify this point, we select also the same point. We verify this. We say this photo interpretation, and we verify our selection area and our selection class. With these two reference verification data, we did the classification of the AVHRR product. At the end, we have a time series for annual data for 33 years from 1982 to 2015. Then we do the accuracy assessment. We evaluate the quality of our data. Each overall accuracy for all the land cover map, product map, and also for every class. Example, which class have good accuracy, example, forest, another type of vegetation, but even the urban class we did. But we found this AVHRR give very good result. We compare the user accuracy and the producer accuracy. It's a statistic interpretation. We compare them and we found that this AVHRR is good for the classification of vegetation. But for example, the burden area didn't give good results.
This is the case, actually, I think this is the AVHRR.
Yeah.
Data with a 1 kilometer
Yeah. Yeah.
which is very broad.
Yeah.
So for specific cases like Tunisia,
Yeah.
I think 80% of the country,
Yeah.
it doesn't work. We need a higher spatial resolution with a lot of ground truthing.
Yeah.
We have a reference for Tunisia, we have reference
Yeah.
results of the second, deuxième inventaire national. C'est la référence pour la haute résolution pour toute la Tunisie. C'est-à-dire qu'ils ont fait à 25 millions. Vous avez même les types d'espèces, les espèces et tout, sur toute la Tunisie. Mais il faut se méfier avec les données globales. Les données MODIS, les données AVHR, les données GlobeCover, les données même. There is a study done by Brown et al. It was a few years ago. It's near real time with Sentinel-2, 10-meter resolution, but it's suspicious. You don't have the validation. You don't have the validation. It can, for example, it can tell you that in the Sahel there is forest, but it's all trees. See.
The best is the field.
Famous work also done 3 years ago with the World Cup of ESA, European Space Agency. It's very good for that, but it needs the validation. So we have to be very careful about with the use of global data in terms of land cover.
I have another question.
Yes.
I like this the dynamic of
Shifting.
the shifting.
Yes.
Very nice.
I didn't, in this presentation, I didn't put everything, but this band in Africa, even from the north part or over also the sub-Saharan part, it's very important. And this is a challenging area for research.
Of course, in your methodology is based on the assessment of big data.
Yes.
This one.
Yeah.
This you don't take into consideration. These are basically on the climate factors.
Yeah.
Right.
Yeah.
And
Yeah.
This is that right?
Yeah. Climate and
This is
vegetation.
Vegetation and
Yeah.
rain, population, and
Yeah.
the crops
Yeah.
or grass. Or
This maps is based on the only on land cover map on vegetation.
vegetation. And
Yeah.
also
No, only this.
after-
No, other indices, climate indices, I use them to quantify and to assess the drought and identify which years is drought or not drought. But the shifting only for the land cover map, it shows the vegetation. I combine all the vegetation types in one class and the desert for second class. And I compare the transition between the dry and wet years to see.
And this approach, I think that it will be more realistic to take into consideration the type of soil, for example. Don't consider the type of soil.
Because types of soil.
Clay soil don't react as sandy soil, for example, even though the same quantity of rain is provided. So,
Because I use big data and I'm working on big area, that's why. But for the small area, yeah.
What I suggest,
Yeah.
because for big data also that of soil is available.
Yeah, I didn't, in my research, I am new in research. I will consider this in my future work. Thank you for your support. Yes. Yeah, thank you for.
Another point is
Yes. Yes.
Like,
No, you can say what you want.
also, the big Sahara, there is a big reservoir of waters.
Yes, I
The sky,
didn't.
right?
I didn't consider this.
The big reservoir for here, another type of thing.
Yeah.
Yes, the groundwater superficial le big réservoir sur la zone, ils peuvent influencer l'extension des surfaces végétales. يعني extension qui permet une simulation تعمل وزي comme ça شيء يعني basically
On remote sensing data, only remote sensing data. Yeah.
اليوم par exemple je parle من زي كلها صح ممكن تمشي زي تلقى كلها جراس كلها واحد على خاطر بس قالوا لنا نديروا فيه فهمتني دونك سي ان فاكتور كي لي زاد دون l'influence des facteurs anthropiques au niveau de l'interprétation des résultats. Il faut en tenir compte d'une fonction la vie.
Oui. I will consider.
Il faut juste quelque chose. Pour noter l'aspect régional, c'est-à-dire c'est toute la zone de l'Afrique du Nord. Donc, une résolution, c'est les résultats dépendent de la résolution. Donc, je t'apprends la résolution, you have to downscale all the data. Which is une task peu difficile, c'est. كل ما ضغط الريزوليوشن على الطائر سي تضغط ال 30 متر 10 متر حتى لو it's complicated task يعني you have to downscale all the data. الداتا اللي تخرج عن 1 كيلومتر ريزوليوشن 1 كيلومتر 500 متر حتى أكثر. دونك الداونسكيل غير بيس هذيك علاش الهوموجينيتي دي دوني والديسبونيبيليتي الهوموجينيتي l'harmonisation voilà. هو سبيل الكلام السيبواسيون الماركة والدية الجنيه اللي يدير بدر بيان يعني إذا كانت تمشي في السكيل أو لو باش نعمل l'Afrique du Nord كلها on se concentre على زون عشان هذا سيرتو بيان avec plus de précision avec plus de بحث الواقع.
Oui. Ce travail, c'est dans le cadre du projet à l'université chinoise. On demandait d'étudier toute l'Afrique. Donc, on a besoin d'utiliser des données à grande échelle.
C'est une étape de départ.
Oui, c'est un travail de départ, oui. I think from 2 years ago, I started working only on South Tunisia with Monsieur Mohamed Wassar and Monsieur Borji Nassif when I come to Tunisia again. But before, I only work on Africa. No, I can't. I want, but I can't. Oui. Les projets chinois, on veut étudier toute l'Afrique. Oui. Les idées, on change les idées. Oui.
Quand on change de on va changer aussi de terminologie sur le 12 et
Ça dépend du choix du sujet. أي أي oui oui Ah. On a déjà travaillé, on a un master. On a déjà. Oui. On a travaillé sur Sentinelle avec une étudiante de master et déjà soutenue le mois de novembre. Oui, on a travaillé sur ces thèmes et sur le land cover, but we used the field data and with more specific details with Monsieur Bajil. Thank you. شكون عنده سؤال؟ هيا يزيد السؤال. تعبت. عندك ملاحظة حذان؟ عندك حاجة؟ Selon les références, based on what is data. We use all. We don't divide the types of crops. It's all C'est l'échelle globale. Oui. هي فهم l'étudiante حرة ديجا خدمت عليهم الحاجات هذو les types de sol les différents معناها type نتاع les crop plant كل شيء par détail عملته خاطر احنا في السود وان بو فير لو تيران فهمت وزون صغيرة نجمو نعملو كل شيء مي لي غران إشياء لازمنا كل مرة نسافرو البلاد نحبو نسافرو سي
قبل كانت التوندونس يستعملوا الكومباريزون تاع لي موديل هيدرولوجي يعملوا الكومباريزون تاع لي ديبي ستاسيون دي جوج يعملوا دي كومباريزون تو التوندونس في ايجيبت هو في سبحان الله la des zones du Sahel مع الستاسيون السويدية ولو يعملوا ليزيماج ساتيليتير يعني يخرجوا الموديل الميديولوجيك les zones inondables, par exemple. Puis comparons à votre images satellites.
Oui. This work is in my PhD work, during my PhD study. I have many other indices, but today I select only CPDSI and some other climate indices. But I have other indices like SPI, DVI, many other indices, and I compare them. But today only I show the calibrated Palmer drought index with the climate and vegetation element. هاي خذ راحتك عادي هنا صافي ذافرو
كنت شفت الجرافيك تاع البوبولاسيون انا في بالي faut être un peu plus méfiant في الانتربريتاسيون تاعها على علاش خاطر اللي لاباريس كيما شفتهم توا سون دي بول دو بوان وحنا نعرف اذا ما درناش حاجه واضحه امونجي حتى ما نعرفش انا في الكاري تخدمي في
الكاري
كنا نياج كنا يا quelque chose de nuage donc on a nuage le fait de parler d'une corrélation c'est pas tout à fait
comment des nuages
وين عندك دي كوريلاسيون
Non, c'est vrai, le nombre de points est très intéressant. Voilà. Par exemple, l'homélie peut-être تبدأ une certaine tendance. Mais par contre, le troisième et le cinquième, سكت شوية باش نحكي على كورلاسيون
هي لو ما خدتش شو مشكل
0,62 0,60 non
قداش الثالثة
70 الثالثة والرابعة 0,64 le bleu لا le bleu 0,65 la troisième 0,70
اكزاكتومون انا على النياج لا شوف راهو النمبر دو بوان تري امبورتون
وهو كثرة نمبر الجمهور
monthly
كل اللي يكون نمبر كبير يكون متعاون في يعني اللاتيس واللي ليش بنقولوا كيلك بار يوصل في دو بار واحدة في جهة طيح هذا برشا ولو ليزيستراب ولو موجودين قال ما يسمى في أوتلايرز يعني
فما إمكانية اللي كنا صغيرين يكون لي زانتيست فهمت عليهم peut-être ما ثماش دي كورلاسيون كلير ما نقدرش نعمل دي كومبينيزون باغ اكزومبل ناخذ انا الفاكتور الاولاني l'espiage de n'importe quoi, mais il y a une combinaison avec un seul facteur. C'est une combinaison de facteurs. C'est une multivariable approche, disons. Multivariation, plusieurs variables à la fois. Partie des résultats pratiques.
Ok, je vais voir ça.
طبعا يعني كانت في كولور عش كولور شوي اللي كان كانوا مخلوقين لي كولور يعني احنا تو هذا لا اللي يقولون ولا الاحمر سكوات
هذاك نورمالمون العكس صحيح. انا لاحظت بقيت نضحك على اخطاء نعم هذه اي معقول لا قبلها زاد لا حتى هذه مش معقول لازم نعملوا انفيرت للكولور صحيح ما هو ديما فما واحد يتعلم ويتطور وفما اخطاء نعملوها في المسيره نتاعو حتى انا كي شفتهم ضحكت على روحي يعني ما نجمش نبدلهم تا والله غير خاطر ما عنديش وقت برشا وقت اي ببليي الارتيكل لا اما مش ببليي معناها بكولرز اخرين فهمتني هذا معناها الاول يعني الخدمه الاولانيه اي ماهوش بالكولور هذا يعيشك اما راهي انا الخدمه الببليي ماهيش كان نور دو لافريك راه نور والويست وبارتي من السنتر دو لافريك اما هذه معناها بارتي صغيره يعني مقصوصه كهو شكون عنده سؤال ها
طموح الصين
الطموح الصيني مازال متواصل ان شاء الله
بالنسبة للرجال هذوما nombre de stations, peut-être moins de stations.
Pas de station. ماهوش بستاسيون من الجلوبال. اي تختار جوست الريزوليوشن اي تختار معناها select الاريا اوف انترست وتعمل داونلود للداتا بعدين الداتا هذوك كيف تعمل لهم داونلود تعمل تنظفهم تعمل لهم سموثينج 1 كيلومتر You have any other question عندكم أي حاجة So
Un très bon travail.
يعيشك
Académique. Il suffit de demander. شفنا برنامج والله مش
Shall we continue directly, Shelley? Can we discuss it?
I think it was like for 15 minutes and then.
Okay, so we want to talk about this. Yes, that's the way. Yeah, okay.
رجولي صديق أنا أخوي المرجو شلون صح ولا ماشي وين جاي ولا صعيب الشيء عشان إن شاء الله
Yeah.
عايز
مستغرب شوية. شو مستغرب شوية؟ أنا عارف إن في دولار شوية.
فين المهم هو شيء عندك كذا بشكل ما يعني That's great.
هي ما كانش كافي
ما فهمنيش يظهر لي حطيته في الصعب نمشي نثبت فيه ترى
صافي شوف هذا
شوف post recording
بالك انا هذه من بعض المدرسة
صافي مزيان